Hello. I will give a short introduction about myself. I'm Timo Pagel. I'm from Hamburg in Germany. I'm a lecturer at the University of Applied Science in Kiel and in Wedel, and I'm an open source enthusiast. So let's come to the agenda. I start with the introduction of the topic. Then we will talk about attack surface reduction, about scanning for known vulnerabilities, and about fast patching. So we start with the introduction. And in 2009, I administered systems. And when I had an uptime like this, my colleagues came and said, wow, you're having a stable system, Timo. So let's map that to containers and to nowadays knowledge. That means that in case I have a container which is running since more than a year, that the container has not been rebuilt since a year. At least when you're having the mutable pattern that you don't want to change containers. So you have no patches. And for the host, it's running on, it's the same. So it also has not applied patches, at least for the Docker daemon, and you have not applied kernel patches, because for that, you still need to reboot your kernel, your system. So let's talk about vulnerabilities and what could happen. So this is the fear part of every security topic. So in 2014, there was a vulnerability called shell shock. It's a privilege escalation vulnerability. And when you have it in your system, it means that you can run arbitrary commands. This is a basic architecture. You have a host, a container, and a service. And when we talk about container outbreak, that means that you have to first attack the service. From there, you need to break out to the container, and then you need to break out to the host, or you might want to break out to the host. And when you reach the host, you might want to gain access to other services because they are more interesting, like databases. So when I'm an attacker, I'm mostly interested on data. And now we map to patch management. So in case you have proper patch management, you might not have shell shock available on the host, so the attacker cannot break into another container. In case you have patch management applied, you might not have a run C container breakout vulnerability. And in case you have a proper patch management, you might not have a vulnerability in engine, so the attacker might not be able to come from the service to the container. So now everyone should have understood that patch management is important, and we continue. So let's talk about attack surface reduction. That is, from my point of view, the first thing you need to do. So it starts with you select a distribution. And what you should consider are the vulnerabilities inside of the distribution, the speed of providing patches, the size, the maintainability, and the stability. I performed a very small research together with a colleague, Henrik Harko. He's also a freelancer like me, but it was very small research, so I can't give you a big picture. You have to figure it by your own. I just give you some impressions how you can select it. Here we have a research, and they figured out due to the packages in various distributions how vulnerable they are. I have to say they looked at public images, so that it's not only the official images, also images which build on top of it. We have Red Hat here with 0% high vulnerable packages. This is interesting, I would say. And 50% have moderate vulnerabilities. Ubuntu has 26%, 26.6 high vulnerable packages, and 80% moderately vulnerable packages. And Debian has only 8.3 in both categories. So I'm not sure about this Red Hat here, why it has 0. So I'm a bit cautious. I'm not sure what is the reason for that. So it might be that they have a fast patching process, so that they patch very fast. I also said that it is that they looked at public images, so it can also be that public images don't use Redshift often. That's why they have not so much. Okay, let's look at maintainability. When you are using Alpine and you would like to use it together with Java, you have to have your own glibc applied. So from my point of view, that is not very maintainable. So glibc, we will see that later also. That's why I explain what it's doing. It's an API to the kernel, so it's responsible for open, read, write, malloc, and other operations which you might know from C. So there is also an additional option. It's called distroless from Google, where you copy only needed files to production images. The downside is that when you only copy the very needed files that are around 5, 6, that you will not even have a shell. So that is bad for developers in case they want to try out something in an image. So that means that you have at least 2 images, 1 production images and 1 image for development. The advantage is obviously that you have less vulnerable files in the image. The disadvantages is also that you need extra knowledge to create distroless images and to maintain it. And in case you scan the original image, because you cannot, I will come to later. I will tell you later why it is hard to scan a distroless image. Because it's based on the package manager, and as you strip away the package manager, you cannot scan it. So you have to scan the original one. So you might have a lot of false positives for packages which are not in the distroless image. You also have to see what is more important, stability or fast patching. When we think about Debian, we have an unstable branch where there are new patches inside, but they are not in the stable branch. So you have to think which branch do you use. So now we come to scanning for known vulnerabilities. Whom of you is actually scanning for known vulnerabilities in images? Okay, a few actually do, very good. If we come to my opinion, you will see my personal opinion about scanning for known vulnerabilities during the talk. So when you want to scan for known vulnerabilities, you have to think about what do you want to scan, how do you want to scan, when do you want to scan, and whom do you report to. So what do you want to scan? You would like to scan the application layer. You also want to scan the virtualized operating system. And you would like to scan the operating system itself. And maybe you also want to scan your hardware. But I have no idea how to do that. In case you have an idea, please tell me. So just to recap, you have a hardware, then you have a host operating system, you have host operating system files, you have a container environment which starts containers, and in a container you find operating system dependencies and the application again with dependencies. So how do we scan? When we talk about the application itself, there are commercial tools like Artifactory, Black Duck, Fossa, White Source, and many others, and open source tools like OWASP Dependency Check and NPM and other things. We won't go more deeper into this because my focus lies on Docker images. When you want to scan the dependencies from the operating system in Docker, you have commercial tools like Anchor, Artifactory, Black Duck, hubdocker.com, Tenable, Container Security, Quay, and others. And you have open source tools like the open source version of Anchor, CoreOS, Clair, and OpenSCAP, and many others maybe, which I don't know. So what is the approach in general? The approach of these tools is first to identify which dependencies and with which version are in the image. And then based on that information, they try to figure out which vulnerabilities are in there. So when these tools try to identify the dependencies and the version, mostly they query the package manager, what is in the package and which version does it have. Some commercial tools do fingerprinting, so they look at the hash sum of the files and identify the vulnerability, the packages. And then some other tools use, in addition, pattern recognition. So they see, for example, when we look at the OWASP dependency check, it is identifying the name and the version. So when it looks up for Java dependencies, and it finds a jar called Apache Commons -2.4. It knows, okay, it is the, or it guesses that it is the Apache Commons in version 2.4. And then it queries vulnerability sources, like the National Vulnerability Database or bug trackers of the systems you're using. So when you use Alpine, it queries the Alpine bug tracker. I have it here a bit more graphically. So this is an example of Clair. So you set up a Clair server. That means you have a Clair process running and a vulnerability mirror. And you can define how often it queries these bug trackers and the National Vulnerability Database. Let's say you do it every 4 hours. So you have a replication here in the mirror or the vulnerability cache. And then you are using a client like Clair. Clair is a client for Clair. And you tell Clair to scan an image with a specific tag. Then it pulls the image from the registry. It identifies the packages. It queries the vulnerabilities for that packages. And it gives a list of the vulnerabilities back to the client. And then you can create maybe an HTML report, or you get it as a structured format like JSON. So now we have a list of vulnerabilities. And now we need to think, what do we do with this list? The first thing we need to think about, from my point of view, are quality gates. So what do we actually want to look at? We might think we accept 10 vulnerabilities, doesn't matter which criticality, or we accept 10 vulnerabilities with criticality high. I implemented the OWASP dependency check with the Jenkins plugin. And what these developers always do is they increment the threshold, especially for high vulnerabilities. They always add +1, +1, +1, but they never decrease it. So in case they release a fix, then they don't decrease it. So that's bad, because then new vulnerabilities are coming inside which you're not aware of. So that is a bad approach. So the better approach is to have a vulnerability management system where you push the test results to, and then in the vulnerability management system, you can accept findings, or you can mark it as mitigated or as false positive. So in case you upload the test again on the next day, the vulnerability management system will know what has been accepted already. And you only get, when here on the way back, you only get new vulnerabilities. One approach, which I often hear, this is a wrong approach, is that you integrate it into vulnerability testing for known vulnerabilities into the continuous integration pipeline. So we have here a developer, he pushes code to the version control, then the build and deployment server performs some tests, pushes the results to the vulnerability management system, and then you might get, hey, there is one finding, then it pushes this to the internal repository in case it's maybe a medium finding which is accepted, and then it's getting pushed to production. In case it's a high vulnerability finding and you have the agreement that high vulnerability finding needs to be handled, an approach is to stop it here so it doesn't go to production, or even stop it here so that it doesn't reach the internal repository. In case we are talking about the developer integrates an SQL injection, then this process is perfect. Because the developer, added the vulnerability. So he is responsible and he needs fast feedback. When we talk about known vulnerabilities, researchers somewhere in the world figured out that there is a vulnerability in a dependency which is already used. So now you're stopping here to push something to production where might be other fixes inside. So that's why I think this is not the right approach. So don't do it. So the correct approach is to have, for example, a second Jenkins file where you check periodically, like once in a day, are the vulnerabilities, and in case there are vulnerabilities, you have a batch. For example, in Jenkins, you have these build status batches, which you can give the developers, and they can put it where they think they often look at. For example, you can embed it into their normal build, so they can see it. But it's not blocking. Blocking is the SQL injection. That should be blocking in case you have a test for that, and it figures out that there is one. Blocking is bad because you're stopping. A better approach would be to say, in case there is a vulnerability, it opens in 7 days in your image, it's criticality high, then we will shut down your system. That would be a good approach. But it's a bad approach to block it here, to say we do not want to add other patches, maybe. So there might be a patch for something, and you're blocking it, because there is a vulnerability somewhere else.
I understand the point you're trying to make, that, yeah, you want those patches, but if you've got a high vulnerability issue, you set that threshold for a reason. Your company doesn't want to take the risk at that level. So if you're allowing that through just because you want those minor patches, that feels like you're accepting a risk that potentially is putting the company at risk, which if you allow that vulnerability through, you're making a conscious business decision, and if you're compromised because of that vulnerability, then the company is liable legally, most likely financially as well, because of that decision to allow that through. So I can't see that passing any sort of compliance auditing.
It depends.
I wonder whether the point is more that through no change from the software company itself, even though you as a company might have a threshold, the point I think is being made here is nothing has changed. What you were shipping a week ago, you're still shipping a week tomorrow. But in the real world, someone has discovered a new vulnerability, marked it as high. So the world has moved on and recognized a flaw that is no more risky than you were shipping a week before. It's just now been made public. But if you had a blocking cross like we have here, you'd be unable to ship it. So if you just have a policy that thou shalt not ship when there is a high vulnerability, you're susceptible to factors outside of your company, because security people that are much cleverer than we are at doing this suddenly say there's a shell shock, so I'm not going to let you ship anything until you patch bash. But that was shipping yesterday. Your customers were live with it yesterday. Today, someone's just made it a high, and you can't move forward. So I sort of take the point here that you can actually, you change that process. So you flag up you've got a high, you make sure everyone knows there's a high, but if you just have a computer saying no, then you're just changing your process to be impacted by all the security.
I will have more arguments for this later, so we should continue now, and then we have this discussion in the end. So now we come to I work for an insurance, so they're in a high regulated environment. How I handle it is that I say everything with criticality high or criticality DEFCON 1. That is how a very critical vulnerability is marked in Clair. Then it must be handled. within a certain amount of time. And when it is low or medium, it should be handled, but I do not check it. So in case they want to, they can check it. My opinion is you're getting a lot of vulnerabilities and you have to analyze them all. We will see later how difficult that is. It will not take you somewhere except wasting your time from my point of view. And when you have the process of looking at what actually got fined for over a year, then you can think about, yes, now I will also add medium findings to my quality gates. But the companies I work for, they started, and when they start, security shouldn't block so much. I don't want to be the bad guy. I want that people live security, they understand it. That is the same when you are implementing the overall dependency check. Don't try to start with medium findings, always try with high and critical findings and nothing else. So let's come to the process to scan images. I guess most of you will have a cluster with multiple nodes and different containers on it. So for example, you have in app 1, image A with tag Z, app 2 with image B and tag Z, and image C with tag Z. And then the thing is that you might have A/B deployments or other things where you have one image here which is not like the others. Or due to a failure, there is an image running which shouldn't run. But luckily, you have a master which knows what's actually running. So now we enhance the picture. So the scan system needs to look at the cluster, get which images are running, and based on that, it should scan. You don't need to scan the whole registry. So basically, when you have a host and not a cluster, you can use Docker PS to get the running containers. And when you're in a cluster environment like OpenShift, you can use the UC tool to get all pods from all namespaces. And then you loop over them, you inspect the container or the pod to get the running image, and then you actually scan the running image with the Clair client CLAR. So now there is a practice tip. When you're using engines, you might want to recompile it because you would like to add some modules. It's not like in Apache where you can add modules easily. You have to recompile it. That means that you have no package manager. When it's not in the package manager, it means that you do not find the dependency and you will not find vulnerabilities. In case you just want to use extra modules and you don't want to have the recent version maybe, then you can use a meta package using the same name with the same version as the original one, and put this meta package and install it during the build. Then you will get the vulnerabilities for it. It's not possible in case the version doesn't match. So now we come to when to scan for vulnerabilities. Here you see that there is a build of an image. Then you give the command, please start the image, and then the container is running. And then maybe you have a periodically build or where you see, there is a new build. But it's not recreating the container. That is, from my point of view, the biggest problem I see. Let us think about the vulnerability lifecycle. So vulnerability gets discovered by a researcher. Then there is a patch published. Then it needs to be built into a package for my distribution. And then in this build, it is included, but as a build, that image here is not starting, not running. I still have that vulnerability in my running container. This is my experience from my clients. Okay. So my clients build it maybe, but they do not start it because there is a manual point where you need to test it. someone with the responsibility needs to click a button. So that is what I see at my customers. I just have 3 customers which are having clusters, so I can only, my experience is based on 3 customers. So now we come to when do you scan? Often you have this kind of image inheritance tree. In practice, it's more complex. You have more images in between. But when we cut it down to the very basic, it looks like this. You have a base image, maybe CentOS. Based on that, you have a DevOps image, like Nginx or Java with a Java application server. And then the projects are just putting the HTML, JavaScript, maybe they add some headers in there, and or when it's Java-based, they're adding the bytecode. Whom of you have ever heard about a RACI matrix? Responsible, accountable, consulted, and informed. Oh, a few. Very good. Yeah, when you talk with information security consultants, they love this RACI matrix. So the DevOps manager is accountable that the DevOps team is performing scans and responding to vulnerabilities. He doesn't have to do it. He's just responsible that the team is doing it. So in case, sorry? Accountable, sorry. He's accountable that the team is doing it. He's not responsible to actually do it by himself. He just needs to make sure that in case someone goes to holiday, that it's getting done. The DevOps team is responsible to actually do it, so they have to respond to vulnerabilities. They have to analyze it. We will see later how hard that is. And in case there is no patch available, and it is a critical vulnerability, they might want to inform the CTO. So the CTO has the option to decommission the system, for example. And customers or the projects should have to be informed about these vulnerabilities based on your organization, how it is structured. Maybe you don't have customers, maybe you just have projects. Depends. So just to make sure you understood, so the application dependencies are managed by the developer, the operating system dependencies in the container are managed by the DevOps team, and the host system files are managed by the DevOps team, or maybe by an infrastructure or platform as a service provider. So this is a general how do you respond to vulnerabilities. You might transfer it. So transfer means that you get an insurance who will pay in case there is a problem happening. I personally don't see this practical for vulnerabilities because mostly they say you have to have proper patch management, so it might be difficult to transfer the risk in case there is a vulnerability. Then you can avoid. That means that you disable a feature or you're using another image with other vulnerabilities, another distribution with other vulnerabilities. You can mitigate it. That in our world means that there is a patch and you apply it. So that would be perfect. Or you accept the risk. So I saw that there are some people here scanning already. Whom of you accept all risks? I see one guy raising his hand. The other ones looks like they don't accept, so they do something. So let us think about what you actually can do. So in case there is a vulnerability in the glibc, you can try to find, you can try to fix it by yourself. That means you will try to find a C or C++ developer who has insights into the glibc, and then you try to fix it. That is, from my point of view, not a realistic scenario. I have never seen that happening for the companies I work for. You can decommission the system. This is something the CTO says, I might want to do it, but he never did it from my experience, no one ever did it. Maybe you decommissioned a system because there is a vulnerability but I never did heard of that. Then, as I said, you can transfer it, but you will not find you might not find an insurance who will take that risk for you. And then you can accept. That means you wait for a patch in the distribution, and this is what 99.999% is what you will do, from my point of view. So the question here, which I raise for the next topic I have, is scanning for known vulnerability versus it. Just to give you an impression, this is an example of a vulnerability. I will read it for you. The XDR bytes and XDR string functions in the GNU-C library, aka glibc or libc 2.25, mishandles failure of buffer decellulation, which allows remote attackers to cause a denial of service with virtual memory allocation or memory consumption if an overcommit setting is not used. We have crafted UDP packet to port 111, a related issue to another common vulnerability and exposure number. So what when I analyze it, I mostly have around 5 minutes. So what I see here is a package to port 111. I look in my container, I see there is no port 111, so I write a report saying this vulnerability very likely doesn't apply. I can't say it doesn't apply, because for that I will need multiple days. Another example, I just want to get you into what will come to you in case you really want to do it. Heap-based buffer overflow in the NSS hostname digits dots function in glibc 2.2 and other 2.x versions before 2.18 allows context-dependent attacker to execute arbitrary code via vectors related to get host by name or get host by name 2 function aka ghost. So what I understand here is that there is a version 2.18 so I can patch. But let's imagine there is no patch. It will be very difficult to analyze this vulnerability. You need a lot of knowledge and a lot of time. I just want to give you an impression what awaits.
You need to think about these things.
Yeah, you will have a lot of analysis. And what you will do in the end, as I said, is mostly you accept it. Okay, here is a graph of community and official images. This is the numbers of reported CVEs of common vulnerability and exposure. So when you're a researcher, you try to get a CVE number for the vulnerability you figured out, so that is this. And especially for images, we have the graph here. And interesting is I couldn't find a newer research, but I think that's also fitting. You see here that there are 500 CVEs and official images per year. When we take that number, 500 vulnerabilities, and I have another research which says 36% of critical vulnerabilities, we will end up that every 2 days you will have an analysis like we have seen here or here. And they might not be as easy as these examples. Okay, this leads me to fast patching. So I think you saw that my opinion is that scanning for known vulnerabilities, you might do it in a highly regulated environment, but I do not recommend to do it for others. You should focus on the part which we have seen before, that you have a fast deployment so that you actually can do something. So in case you want to do fast patching, you will have a process like this. You pull external images, you perform upgrades or updates, you build the project image, you test the images, and you destroy and start containers. Just to recap, why do you need to update packages during the build? When we look at CentOS, for example, it's updating its images once in a month around. So there are 4 weeks where vulnerabilities might raise, which are not patched. So you have, during your own build, you have to apply packages. Then another thing which I discovered is, it's pretty hard. In CentOS, there is documented that you can use yum update -- security. And the documentation says, or claims that in case you're using the parameter security, it will look at the update info.yaml.xml in which is listed which packages has vulnerabilities. In CentOS, this is as you know, CentOS is based on Red Hat. So in Red Hat, you really have this functionality. In CentOS, the update info.xml is not present, and in 2009, they claimed in their bug tracker, we do not support YAML security. So what actually happens, and they haven't, you should have some knowledge when you go out here about security. So one pattern is fail secure. So in case it is not there, I expect that I get an error. In case the update info.xml is not there, I expect to get an error. But what actually happens is that this YAML assumes there is no vulnerability because there are no entries. That is so hard. Okay. Some other hints. For sure, you should, when you build an image, you should use a no cache parameter. When you are in a cluster, you should use image pull policy always, so that you always get the recent version, and you should whitelist an internal registry for images and deny all others, so that your developers don't use images which they are not supposed to. I guess everyone knows this, but just to have it inside of the talk, when you're rebuilding CentOS and there is a new image, it should have a hook to inform that the engines need to be rebuilt and the Java application server need to be rebuilt and that the project images also needs to be rebuilt. So we come to the conclusion. When you're using the nightly build and deploy, so fast patching, it's good for external images. You have a high testing requirement because you actually need to test it before you want to release it, at least in my environments. You should have continuous delivery in the best case to do it. And when you do scanning, you're not blind, so you know that there is a vulnerability. As I said, you might not be able to do something about it. You have a high effort in analyze it, so it is very time consuming. So my conclusion is patching is not easy. Detection of vulnerabilities in running containers might be done. Quality gates are important, especially to use a vulnerability management system. And you should enhance the possibility to deploy fast. That would be the first step from my point of view. And when you have that, you can go to the next step.